All right, picking up right where we left off, like I was saying, the very first thing we have to do is find f of x plus h. Now, this is a composition of functions because it's telling me that I need to plug x plus h into f of x. So everywhere I see an x, I am going to replace it with the quantity x plus h using my parentheses carefully. So, first thing I need to find is f of x plus h, and this is going to equal 2 times the quantity x plus h squared minus x plus h, and then I have that plus 1 coming along. Now, as in a previous example, remember that first thing we have to do is follow those order of operations. I've got to square that quantity x plus h. And when I do that, I really am going to have to FOIL out x plus h times the quantity x plus h. So when I do this, I'm going to get x squared plus xh plus xh plus h squared. Now, keep in mind, I also have that 2 in front, so I now am left with 2 times x squared plus, and I'm going to combine those two middle terms to give me a 2xh plus h squared. I'm going to go ahead and distribute and get minus x minus h, and then I still have my plus 1 here. All right, in my next step, I'm going to distribute this 2. So now I'll have 2x squared plus 4xh plus 2h squared minus x minus h plus 1. Now, at this point, realize that none of these terms are like terms, so that right there is f of x plus h. So when you come across this in your homework, and the first thing it asks you for is f of x plus h, you should expect to get out a long expression here. Let me try that again. There we go. So 2x squared plus 4xh plus 2h squared minus x minus h plus 1 is f of x plus h. Now, in part 2, I need to take f of x plus h and subtract from it f of x, and then divide that entire expression by h. So, here's what we've got. I'm going to make some room for us here. So we are looking at part 2 here, and it tells me to take f of x plus h, which I just found out. So f of x plus h is 2x squared plus 4xh plus 2h squared minus x minus h plus 1. And now I need to subtract from that f of x. Now, keep in mind, they have already told me what f of x is. F of x equals 2x squared minus x plus 1. And I'm subtracting off that entire quantity, so I'm going to make sure that I subtract off and use parentheses here. So I have 2x squared minus x plus 1. And this entire expression is going to be all over h. All right. In my next step, I'm going to just copy over f of x plus h again. 2x squared plus 4xh plus 2h squared minus x minus h plus 1. And now I'm going to distribute that negative through to my f of x. I'm going to have minus 2x squared plus x minus 1, and this whole expression is over h. You definitely cannot be afraid of long expressions and writing things out, because you're going to find that that's what happens in the difference quotients. But the beauty of it all is that as we use the difference quotient, we are going to find out that when I combine like terms, a lot of things are going to go away. 2x squared minus 2x squared, see you later. What else? Minus x plus x, peace out. Positive 1 minus 1, see you later. So all I'm left with at this point is 4xh plus 2h squared minus h all over h. Now, if you look at the numerator, you're going to see that 4xh plus 2h squared minus h, each one of those terms actually has an h in it. So I'm going to be able to factor that h out front, and I will have 4x plus 2h minus 1, and then I still have that h in the denominator. Now, because I have a factor of h in the numerator and h in the denominator, those are going to reduce, and I am going to be left with 4x plus 2h minus 1. And that right there is my difference quotient. That is the answer to f of x plus h minus f of x all over h. So we get 4x plus 2h minus 1. All right, now the last topic in here is function decomposition. These ones I think are actually really fun, but you know, I'm a little wacky like that. Now, in function decomposition, it's going to be important for us to really pay attention to what's on the inside and what's on the outside. Now, decomposition, we're going to break things apart, okay? We're going to get its original pieces of f of x and g of x. So I have a function here that they're calling h of x that's equal to the square root of 3x minus 5. And I need to find the original two functions that were put together to make h of x. But I'm really just working backwards here. Now, when I look at this, what I really want to ask myself is, what is my inside function? Now, notice notation-wise, my inside function is f of x. But as I look at this and I'm asking myself what the inside function is, when I look at my actual function of the square root of 3x minus 5, I want to use those grouping symbols to my advantage, okay? Inside that square root is 3x minus 5. So my inside function of f of x is going to be inside that square root of, and it's going to equal 3x minus 5. So use grouping symbols like square roots, parentheses, those kinds of symbols to your advantage. That's what's telling you what your inside is. Now, I found f of x, it's 3x minus 5, it's my inside function. Now I need to find my outside function, which would be g of x. Now my outside function in this case is that square root. So g of x is going to simply equal the square root of x. Now what's nice about these is if I did want to, I could easily check my answer. I could go back and say, okay, well, based on these two functions that I just decomposed into, what would g of f of x be? What would happen if I plugged f of x into g of x? I would get the square root of 3x minus 5. So these ones are nice and easy to check yourself as well. All right, one more function decomposition. This time we are looking at h of x equals 2 over the quantity x plus 3 squared. Now again, we really want to take that inside-outside approach again, using those grouping symbols to help yourself. So my inside function, my f of x, is going to be inside those parentheses. So inside those parentheses is that x plus 3. So f of x equals x plus 3. Now, as I look for my outside function, I'm saying, okay, well, what else was left out on the outside? That's going to be my g of x. Now, in this case, my g of x is going to be 2 over something squared, but I've got to put that x there as a placeholder. So I'm going to have 2 over x squared. And again, real easy to check ourselves if we want to. If I plug that x plus 3 in, I would find out that g of f of x equals 2 over x plus 3 quantity squared. So these ones are really just working backwards, looking for those original functions f of x and g of x. But keep in mind, inside, outside is important. Use those grouping symbols to your advantage. Okay? As always with anything, if you have questions from anything we've worked through, please reach out to me, email me, message me through your homework. I'm here to help you. Have a great day. Bye.